You are sitting here watching this video, probably assuming that you exist and that there is a video. Maybe you're watching it on your phone in your room and it all seems perfectly normal. The walls around you are your floor, your body. All of this appears to be solid, stable, and obviously real. But here's the problem. Physicists are no longer certain. In fact, some of the smartest people on Earth, those who have devoted their entire lives to trying to understand reality, are beginning to say something deeply disturbing. They don't just say that the universe is strange or mysterious or difficult to understand. That's old news. What they are saying now is that the universe may not exist. Not in the sense that we think, or maybe not at all. Not as something out there. Not as a physical system with objects moving in space and time. Not as an objective reality that would still be here if you weren't there to see it. And this isn't some clickbait science fiction idea. These are real questions that are asked in actual academic articles, discussed at physics conferences, and published in peer-reviewed journals. What began as cracks in the foundation, strange quantum experiments, paradoxes about time and space, expanded into something no one expected. The idea that reality may be nothing more than a set of relationships or calculations or experiences without any physical basis at all. We are going to go through real research on the theory, experimental results, and philosophical implications that most physicists avoid talking about publicly. But we are not here to repeat hackneyed quantum paradoxes or say vague things like reality is an illusion. We are going to see how physicists construct serious models suggesting that the universe as we have always imagined it may not be real at all. That everything we take for granted is just a kind of user interface, similar to the icons on your phone that hide the true foreign structure of what lies beneath. And by the end of this journey, you may begin to wonder if the universe does not exist. Then what does exist? Because if space and time are emergent, if particles are just vibrations in invisible fields, if reality itself depends on the observer, then who or what is observing? Let's start from the beginning, and let's follow the path of physicists who dared to ask questions. What if there never was a universe? Let's start with something most of us never question. The idea that there is a world out there. Something real, physical, solid, existing independently of whether you look at it or not. This assumption underpins almost everything we do. You touch the table. It seems solid. You drop your phone and it falls. You look at the stars and assume that they are really there. But there is a problem hidden within this assumption. A simple but awkward question. As you know, not what you believe or what you have been told, or what works in everyday life. How do you know that what you see, touch, and hear really exists independently of you? You might say, well, I can see that. But that's not reality. It's perception. And the more you delve into how perception works, the more disturbing it becomes. You see, your brain does not show you the world. It shows you a model of the world. A guess. Simulation. It takes electrical signals from your eyes, ears, and skin and reconstructs something that makes sense. And the key word here is reconstructs. You don't see the real world. You see a simplified abstract version, filtered, interpreted, edited for survival. This is not philosophy. This is neurobiology. What you perceive as color, for example, does not exist in the world. It's in your head. Light has no color. It has a wavelength. And there is nothing red or blue in these wavelengths. It's just energy. Color is your brain's translation of certain frequencies of light into a visual code that humans can understand. Other species perceive color differently or not at all, depending on their biology. The same applies to sound. Air molecules vibrate, but the sound of a car horn or your friend's voice only exists when your brain turns these vibrations into something recognizable. So the world you think you live in is not really there. It happens here, inside your head. Now let's take another step. A growing number of scientists and philosophers, such as cognitive scientist Donald Hoffman, argue that our brains do not simply simplify reality. He can completely hide it. His research shows that evolution does not favor accuracy. It promotes usefulness. In other words, your feelings evolved not to show you the truth, but to survive. Think of it as a computer interface. When you drag a file to the trash can on your desktop, you are not literally pushing digital particles into a garbage can. This is a visual metaphor. A trick to make something complicated seem simple. And according to Hoffman, that's exactly what reality does to you. Every object, every color, everything you see is just an icon. User interface. A way of interacting with something that is immeasurably more complex at its core. With something your brain could never truly comprehend. We cannot see the truth. We see what we need to see in order to survive. Just as a file icon on your computer screen helps you navigate without understanding all the underlying electrical signals. It sounds wild, but it also fits with quantum mechanics. Hoffman's team conducted mathematical modeling showing that agents who saw the world as it really was lost. Every time. They were surpassed in the competition of evolution and destroyed. The winners were those who saw nothing of the truth, only useful reductions. So what if this table isn't solid? What if your phone isn't actually here? What if the stars, the sky, your hands, your voice are just visual effects for an internal system that is not at all what you think it is? This may not just be a metaphor. It could be physics. Until now, most people assumed that the smallest building blocks of the universe were particles. Tiny, indivisible pieces of matter flying through space, colliding and interacting. Electrons, quarks, neutrinos. This idea has been around for centuries and still dominates how we talk about reality. But here's the truth. Particles are not real. Not in the sense that we think. In modern physics, there are no small points floating in space that actually correspond to experiments. What we call particles are merely visible symptoms of something deeper. They are not the base layer. They are effects, flashes, the results of excitations in something more fundamental in quantum fields. This is no longer a theory. This is the accepted basis of elementary particle physics. The standard model, which explains all known particles and forces except gravity, is entirely based on fields, not on matter, not at the facilities. In the fields, continuous entities that extend throughout all space. Every type of particle you have ever heard of, electrons, photons, Higgs bosons, is actually just a ripple in its corresponding field. Imagine the field as an invisible ocean, but one that fills the entire universe. He's always everywhere. When he is calm, you see nothing. But when it vibrates in a certain way, ripples are formed. This ripple is what we detect as a particle. An electron is not a tiny ball flying through space. This is a small localized excitation in the electronic field. A photon is an excitation in an electromagnetic field. The world is fundamentally empty and consists not of things, but of the potential of these fields. If everything consists of fields, then there are no solid things, only temporary energy patterns. The particles that form atoms, which build molecules that make up everything you see, are simply interactions of fields. But this fabric is strange. Unlike classical fields, quantum fields are inherently uncertain. Their behavior is statistical rather than definite. Even in their lowest energy state, the so-called vacuum, quantum fields still oscillate. These fluctuations are measurable. They are responsible for phenomena such as the Casimir effect, where two metal plates in a vacuum experience a tiny force due to the energy in the empty space between them. So think about it. Even a vacuum is not truly empty. What looks like nothing is actually buzzing with activity. Particles appear and disappear, fields flicker and interact below the detection threshold. The emptier space still contains the seeds of everything. This means that emptiness, as we understand it, does not exist. What we consider to be the last bastion, an unshakable backdrop for reality, is itself a dynamic arena full of potential. Nothing is empty. Nothing is passive. The last reliable constant in our world turns out to be yet another illusion, yet another active process concealing its true nature. The foundation of the world, which we considered passive and empty, is actually full of energy and possibilities. This undermines the very concept of non-existence. You may ask, if all this is just fields, why does the world seem solid? The answer is that hardness is a large-scale effect. It arises because atoms, which are mostly empty space, interact through electromagnetic forces. When you press your hand against a wall, what you feel is not matter hitting matter. This is the repulsion of fields. Two sets of energy distributions overlap and resist compression. The experience of hardness is an illusion created by quantum rules playing out in highly organized systems. This completely changes the rules. If there are no solid objects or real physical contact, then our most basic experience of interacting with the world does not exist. Consider this. Every memory you have of touching something, from a handshake to the feeling of the ground beneath your feet, is based on a fundamental misconception. You never touched anything. You have never experienced direct contact. You have always been separated from the world by an invisible force field. Every physical interaction in your life has been an interaction at a distance, an illusion of closeness generated by the repulsion of invisible forces. The world you have built based on your tactile experience is a phantom world. The idea of no borders goes even deeper. What we call objects, chairs, atoms, even people, are not actually discrete entities. They are temporary energy configurations structured by invisible laws. There is no clear boundary between you and the world. You are not a sealed unit. You are part of the system, process. You constantly exchange particles of energy and information with everything around you. You breathe in atoms that were once part of other people. The carbon in your body was forged in stars. And at the quantum level, the difference between you and not you becomes blurred and uncertain. Where does your body end and the air you breathe begin? On which atom does this line pass? The answer is simple: none whatsoever. The boundary you feel between yourself and the rest of the universe is a conceptual boundary, not a physical one. This is a convenient shortcut created by your brain so that you can function as a single agent. But at a fundamental level, you are not separate from the world. You are a world experiencing itself locally. You are not a drop in the ocean. You are the whole ocean in a single drop. This idea dissolves the very concept of an isolated I and transforms us from separate beings into intertwined patterns in a single universal fabric. The idea that an electron here is the same as an electron there only makes sense in field theory. There is no such thing as this electron or that electron. They are indistinguishable because they are not separate objects. They are all simply excitations in the same universal field. What we consider to be a multitude of particles are simply different instances of the same basic vibration. In a very real sense, all electrons are the same electron, not metaphorically, literally. They are not clones or copies. It is the same pattern appearing again and again in different places because the field is everywhere. This implies that the distinction between objects may be a human construct. What we perceive as separation, this particle versus that object versus the next, is simply how our brain divides a continuous, fluid system into digestible pieces. Consider the consequences. If all the fundamental components of your body are not unique, but are merely repetitive examples of universal patterns, what makes you unique? Your form, your structure. But this structure itself is built from completely interchangeable parts. This undermines not only the uniqueness of objects, but also the very foundation of our own individuality. We consider ourselves unique snowflakes, but we are built from standard bricks that are no different from the bricks that build a star or a stone. Let's put it all together. The world we perceive is not what it really is. Our perception is a user interface evolutionarily tuned for survival rather than truth. This interface shows us a world of solid, separate objects, but physics tells us that this is a lie. At a fundamental level, there are no objects. There are only quantum fields. What we call matter is simply localized vibrations in these fields. What we perceive as solidity is simply the repulsion of these fields from each other. No real contact ever occurs. The boundaries between objects, including ourselves, are artificial constructs. We are inextricably linked to the entire universe, and even the building blocks of this universe do not possess individuality. All particles of the same type are merely interchangeable manifestations of the same basic field. Every pillar of our intuitive world has been knocked down. Matter, solidity, contact, separateness, individuality, all of these turned out to be layers of one big illusion, a structured deception that allows us to navigate a reality whose true nature remains hidden. We live inside a coordinated hallucination. So, nothing is solid, nothing is separate, nothing is unique in the sense that we are accustomed to thinking. Everything that you consider to be the reliable foundation of the world, the rock beneath your feet, the table on which your computer stands, your own body, is all emptiness, structured by invisible rules, a dance of energy in the abyss. And this is not just a philosophical exercise. It is a direct conclusion from the most successful and proven scientific theory in human history. We are forced to accept the fact that the most fundamental aspect of our experience, the materiality of the world, is an illusion. This is the first and most shocking layer of deception. Realizing this causes a deep existential horror. The ground is slipping away from under our feet. The reliable and predictable world evaporates, leaving us alone with structure and emptiness. Everything we relied on turned out to be a ghost. And if even matter itself is a deception, what else can we rely on? This conclusion does not simply change our view of the world, it destroys it, and it forces us to ask an even more disturbing question. If matter is an illusion, what about the stage on which this ghostly spectacle is played out? We are accustomed to considering space and time as an absolute backdrop, an unchanging container in which the universe exists. Space is the void in which everything exists. Time is the river that carries everything forward. These are such fundamental concepts that we cannot even imagine a world without them. They are the operating system of our thinking. But we have just seen how the illusion of matter collapsed. We have discovered that the actors on the stage are ghosts. Now we must gather our courage and ask the next question. Does the stage itself exist? What if space is not emptiness, but something completely different? What if time is not a river, but another complex illusion? We are moving from the question, what is the world made of, to the question, where and when is it located? And the answer offered by modern physics may be much more shocking than anything we have discussed so far. Get ready. Because the next idea doesn't just break intuition, it breaks reality itself. We are going to explore the possibility that space-time itself, the great arena of the cosmos, is the greatest deception of all. We stand on the ruined foundations of the material world and gaze into the abyss. But even in this emptiness, it seems to us that we have one remaining source of support. One last unshakable arena in which events unfold. Space. We consider it an absolute given. A smooth, continuous, empty vessel for all that exists. You can mentally divide any segment in half, then again, and again, ad infinitum. Intuition tells us that this process has no end. Space seems to us to be an analog, infinitely divisible background for reality. But what happens when we try to apply our best scientific theories to this background? What would happen if we took Einstein's general theory of relativity, which describes the geometry of space, and quantum mechanics, which describes behavior within it, and forced them to work together on the most microscopic scales? The answer is simple. Everything breaks down. The equations produce meaningless infinities, and this failure points to something incredible, on the existence of an absolute limit. There is a scale below which the very concept of space loses all meaning. This limit is known as the Planck length, 1.6 to the power of minus 35 meters. To imagine how small this is, think of an atom. Now increase it to the size of the entire observable universe. The Planck length at this scale would be the size of a normal tree. Below this level, geometry ceases to function. The concept of distance or location dissolves in quantum uncertainty. Space ceases to be smooth. It breaks down into discrete, indivisible units, into quanta, on the pixels of reality. This means that our smooth and continuous universe is only an illusion, image with final resolution. We live inside a digital picture that seems analog only because we cannot see its individual pixels. Space, not forever. It has a limit, permission, our reality. This is an image, and if that is the case, then the most important question arises. If space is just pixels, then what is between them? And what or who creates this image itself? The idea of pixel space in itself destroys our worldview, but it only prepares us for an even stranger and more counterintuitive property of our reality. A property that proves that these pixels are connected in ways that do not obey the laws of space itself. This phenomenon is called quantum entanglement. Imagine that you have two particles created together in such a way that their properties are interrelated. For example, their backs should be opposite. If one rotates upward, the other must rotate downward. Now send these particles to opposite ends of the galaxy. There are billions of light years between them. According to common sense and classical physics, measuring one particle should not instantly affect another. Any influence cannot propagate faster than the speed of light. But quantum mechanics predicted the opposite, and experiments confirmed this with 100% accuracy. At the very moment when you measure the spin of the first particle, and it turns out to be pointing up, the spin of the second particle at the other end of the universe instantly becomes pointing down. Instantly. Without any delay. Information between them is transmitted faster than the speed of light, which seemed impossible. Einstein hated this idea. He called it spooky action at a distance, and was convinced that it proved the incompleteness of quantum theory. He believed that particles have predetermined hidden properties, but numerous experiments have proven Einstein wrong. There are no hidden instructions. Particles do indeed influence each other instantaneously, ignoring any distance. This is a violation of the principle of locality. This is proof that, at a fundamental level, there are connections that exist outside of space. Who don't care about distance? They do not travel through space. They ignore him, as if he simply does not exist for them. This means that the universe is not local. There is a deeper level of reality where everything is connected in a way that is completely different from what we are used to thinking. Spooky action at a distance, stumped physicists. How can two particles be connected across cosmic distances without transmitting any signal? This violates everything we know about causality and space. But in recent years, a radical and stunning hypothesis has emerged that offers an answer. What if particles do not send secret signals to each other through space? What if they are connected directly through a hidden dimension via a kind of tunnel or wormhole? This idea is known as the ER-EPR hypothesis, formulated by physicists Juan Maldacena and Leonard Susskind. EPR refers to the Einstein-Podolsky-Rosen paradox, i.e. entanglement. ER refers to Einstein-Rosen bridges, better known as wormholes, theoretical tunnels in the fabric of space-time. The hypothesis asserts that these two phenomena are actually one and the same. Quantum entanglement and the geometry of space-time are two sides of the same coin. When two particles are entangled, they can be connected by a microscopic wormhole. Their instantaneous connection is not action at a distance. This is a direct connection through geometry. They are not far from each other. They are simultaneously far away in ordinary space and close by in this hidden network of connections. Now expand on this idea. If every pair of entangled particles creates a tiny Einstein-Rosen bridge, then perhaps the entire fabric of space is woven from these quantum threads. Imagine a giant web consisting of billions and billions of such holes. This web is space, smooth and continuous at the macro level, but actually constructed from discrete quantum connections. This means that space is not just emptiness. This is the structure, a complex network of connections generated by quantum entanglement. It is not fundamental, it is emergent. It arises from these deeper non-local interactions. The world that seemed to us to be an empty vessel turns out to be an incredibly complex and intertwined structure. If space is woven from threads of entanglement, then this completely overturns our understanding of distance. We are accustomed to thinking of distance as a fundamental absolute quantity. A meter here is the same as a meter at the edge of the universe. But in this new picture of the world, distance ceases to be a primary property. It becomes secondary emergent. It becomes a measure of confusion. Imagine two regions of space. The more quantum particles in these regions are entangled with each other, the closer these regions are to each other in this fundamental network. The less confusion there is, the further apart they are from each other. Distance, as we commonly understand it, is simply a macroscopic reflection of the density of these quantum connections. Let's conduct a thought experiment. Let's take 2 points in space and begin to systematically destroy the quantum entanglement between them. In our world, we wouldn't see anything special. But at a fundamental level, these 2 points will begin to drift apart. The space between them will stretch and grow, not because they are physically moving, but because the information connection between them is weakening. Conversely, if we can artificially increase the entanglement between 2 distant points, we can stitch the space between them, creating a short path. This means that space is not an inert background. It is a dynamic structure that can be constructed and deconstructed by managing information and complexity. It's like how on social media, 2 people can be close to each other if they have many mutual friends and connections, even if they live on different continents. Their distance is determined not by kilometers, but by the strength of their connection to the network. Perhaps our universe works the same way, and the distance we measure with a ruler is only a rough approximation of the true informational geometry of reality. Space is not where things are located. Space is how things are connected. The idea that space arises from information leads us to one of the most profound and disturbing concepts in modern physics, to the holographic principle. First proposed by Gerard 't Hooft and developed by Leonard Susskind, this principle originated from the study of black holes. Physicists have discovered a strange fact. The maximum amount of information that can be contained within a given volume of space, for example inside a black hole, is not proportional to that volume as one might expect. It is proportional to the surface area surrounding this volume. It's as if all the information about the contents of your house were written on its walls, but there was nothing inside. This conclusion led to a stunning idea. Perhaps our entire 3-dimensional universe is a kind of hologram. A hologram is a 2-dimensional surface that creates a 3-dimensional image when illuminated. The holographic principle suggests that our reality may be structured in the same way. All information about our seemingly 3-dimensional world, with all its galaxies, stars, and us, can be completely encoded on some distant 2-dimensional boundary at the edge of space. What we perceive as movement, depth, and volume may only be a complex projection generated by this flat information structure. We do not live inside the 3-dimensional universe. We can be the image she projects, ghosts in the car. This is not just a metaphor. A mathematical apparatus known as the ADS-CFT correspondence has shown that a certain theory of gravity in 5 dimensions can be mathematically equivalent to a quantum field theory without gravity on its 4-dimensional boundary. This proves that the holographic principle is at least mathematically possible. This creates a profound sense of derealization. The world that seemed so real and 3-dimensional may turn out to be nothing more than a complex illusion, projected from an invisible screen. We can be characters in a 3-dimensional film whose script is written in 2 dimensions. We destroyed space by turning it into an emergent holographic projection. But what about his partner? What about the time? Time seems even more fundamental to us than space. It is a continuous flow that carries us from the past through the present into the future. This is the very fabric of experience. But just as in the case of space, When physicists try to describe the universe as a single entity at the most fundamental level, time disappears. One of the key equations in attempts to unify general relativity and quantum mechanics is called the Wheeler-DeWitt equation. It describes the wave function of the entire universe, but there is no time variable in this equation. Not at all. According to him, the universe as a quantum system does not evolve over time. It just is, static and eternal. All possible configurations of the universe, from the Big Bang to its end, exist simultaneously in a kind of timeless space of possibilities. This creates a feeling of claustrophobia and fatalism. If time does not exist at a fundamental level, then everything that has ever happened and will ever happen is already predetermined. It already exists. Freedom of will becomes an illusion, and the passage of time itself becomes a mystery. If reality is based on timelessness, then where does our powerful and irrefutable sense of flow come from? Why do we remember the past but not the future? Why do we feel that we are moving forward? This problem of disappearing time is one of the deepest mysteries in physics. She suggests that time, like space, is not part of the fundamental fabric of the world. It is not embedded in reality. It is created somehow, perhaps by us. This means that the most fundamental aspect of our existence, moving through moments, may be the greatest deception of all. We may be frozen figures in an eternal landscape who dream that they are going somewhere. The idea that time does not exist at a fundamental level leads us to a model known as the block universe, or eternalism. This point of view suggests that time should be considered as another dimension similar to the three spatial dimensions. Just as all points in space exist simultaneously, all moments in time, past, present, and future, also exist simultaneously. The entire history of the universe, from its beginning to its end, represents a single four-dimensional block. Your birth, your first kiss, what you're doing right now, and the moment of your death. All of this already exists as part of this eternal, unchanging structure. Our consciousness, like a flashlight beam, illuminates successive slices of this block, creating the illusion of movement and the passage of time. We do not move through time. We are simply experiencing the sequence of what already exists now. It's like reading a book. All pages and events exist simultaneously from the first to the last. But as a reader, you perceive the story sequentially, page by page, or to watch a movie. All the frames already exist on the film, but the projector shows them one after another, creating the illusion of movement. This model logically follows from Einstein's theory of relativity, which shows that simultaneity is relative. Two different observers may disagree about what events are happening now. The only way to reconcile their points of view is to assume that all events simply exist. This creates a deep sense of inevitability and helplessness. If the future is already written, what is the point of our choices and actions? We become puppets in a cosmic play whose script has already been written. Our life is simply a route along a map that has already been drawn. And although this idea seems philosophically suffocating, it is one of the most logical consequences of our best theory of gravity. But if the entire history of the universe already exists as a single block, why do we so clearly and irreversibly feel the arrow of time pointing from the past to the future? Why do we remember yesterday, but not tomorrow? Why eggs break, but never get put back together? The answer to this question is provided not by fundamental physics, but by statistics, the second law of thermodynamics. This famous law states that in a closed system, total entropy, i.e., the measure of disorder or chaos, can only increase over time. The universe began in a state of very low entropy, incredibly orderly and improbable. Since then, it has been steadily moving toward a state of increasing disorder. And it is precisely this process that we perceive as the passage of time. Our sense of forward is simply a direction toward increasing chaos. It is not a fundamental law of nature in the same sense as gravity. This is a statistical trend. Imagine a room with air gathered in one corner. This is an orderly state. If you wait, the the air molecules will spread evenly throughout the room. This is a state of disorder. There are infinitely more ways for molecules to be disordered than ordered. Therefore, the system naturally moves toward chaos. And this process is irreversible. In the same way, our universe is moving from order to disorder. And this path is what we call time. This reduces us and our experiences to statistical error. Our existence is only possible in this phase of entropy growth. We are complex, orderly structures that can only exist by burning order and creating disorder. We are waves of order in an ocean of growing chaos, and the flow of time that we perceive is simply the sound of this decay, the sound of a dying universe. Let's take a step back and look at the ruins. We began with a firm belief in the existence of space and time as an immutable arena for all events. Now we see that it was just an illusion. Space is not a fundamental void. It is emergent. It arises from a deeper network of quantum connections. Just as an image appears on a screen, its smoothness and continuity are a large-scale effect that conceals its discrete pixel nature. Its geometry is determined not by distances, but by the density of information and entanglement. It may even be a holographic projection. Time is also not a fundamental flow. At the most basic level, it does not exist. Our universe may be a static four-dimensional block in which all events exist simultaneously. And our perception of the passage of time, its irreversible arrow, is not a property of the universe itself, but a statistical tendency toward increasing disorder in complex systems such as ourselves. Space and time are not what we live in. This is what we or the system itself generates. They are a product. The result, a side effect of deeper and more abstract laws that have nothing to do with our intuitive experience. They are not a stage. They are part of the scenery. And as in the case of the illusion of matter, they represent a kind of user interface, a convenient operating system that allows us to interact with reality without understanding its true structure. It gives us the concepts of here and there, before and after. But behind the scenes of this operating system lies something completely different, something that is neither spatial nor temporal. We have come to a conclusion that cannot be avoided. There are no real solid things. There is no real stage on which they could exist. Everything we have ever considered to be the universe, its matter, its space, its time, is a user interface. A complex multi-level illusion generated for us or by us from a deeper and more incomprehensible structure. This thought evokes a profound existential dread. This feeling of complete and utter disorientation. If the world around us is not reality but only a representation of it, then where are we really? If there is no here or now, then who are we? We become digital avatars in a game whose rules we don't know and whose creator we have never seen. Every action we take, every experience we have, becomes suspicious. Is it genuine or just part of the program? Is this table real, or is it just a set of data rendered for my perception? Is the love I feel a genuine emotion or an emulation of a complex algorithm? This idea is scarier than solipsism. Solipsism asserts that only my mind exists. This idea suggests that even my mind may be only part of the interface, pattern in the system. This is the final destruction of the support. We didn't just lose our footing, we discovered that there had never been any soil or feet. We are ghosts floating inside another ghost that we called reality. And our entire world, with all its beauty and pain, may turn out to be no more real than a dream from which it is impossible to wake up, because awakening implies the existence of another, more real room. What if there are no more rooms? What if this is the only dream there is? The realization that we live within an interface inevitably leads us to the next logical step. Any interface implies a user. Any image implies a viewer. If reality is a representation, then who or what is the audience? This question brings the most uncomfortable and controversial element for all of science to the center of the whole picture. Observer. For almost 400 years, science was based on the principle of objectivity, on the idea that the universe exists on its own and we can study it from the outside as impartial witnesses. Our task was to exclude ourselves from the experiment as much as possible, so that our measurements do not affect the result, so that our theories describe the world as it is, not as we want to see it. This principle has enabled us to achieve incredible heights, but now we have reached the point where this principle ceases to work, where the very idea of dividing into observer and observed becomes meaningless. Quantum mechanics has shown us that the act of observation fundamentally changes what we are looking at. And now, the hypothesis of the universe as an interface tells us that without an observer, there may be nothing to observe. We have reached the edge of an abyss that physicists have been trying to avoid for almost a century, to the most scandalous and heretical idea in science, to the idea that reality may not exist until you look at it, that the universe is not a pre-existing fact but a dialogue, and we are one of its sides. We are heading into the darkest and most confusing forest of modern physics, where objectivity dies and something much stranger is born. We arrived at the epicenter of an earthquake that has been shaking the foundations of science for almost a century. Up until this point, our entire journey had been preparation. We broke down matter into its constituent parts, transforming it into field vibrations. We dissolved space and time by making them an emergent projection. But all of this could somehow be fitted into a modified, yet still objective picture of the world. One could imagine that behind the interface there was simply another stranger physics. But now we have come to an idea so radical, so contrary to the very essence of the scientific method, that most scientists still try not to think about it. We have come to the problem of the observer. For almost 400 years, modern science has been built on one unshakable foundation, based on the principle of objectivity, on the dream of God's gaze. The idea was simple and elegant. There is only one objective universe that exists independently of us. It obeys eternal and unchanging laws, and the task of a scientist is to be an impartial witness, a passive observer. He must construct his instruments and theories in such a way as to exclude himself from the equation as much as possible. To see the world as it really is, not as our presence makes it. Galileo observing the movement of the planets, Newton deriving the law of universal gravitation. Laplace dreamed of a demon who, knowing the position and velocity of all particles, could predict the entire future of the universe. This whole paradigm was built on division. There is a subject, a scientist, and there is an object, the universe. And between them lies an insurmountable chasm. A scientist can describe an object and study it, but he must not influence it by the very fact of his study. This principle was the source of science's power. He enabled us to separate facts from opinions, knowledge from superstition. He gave us technology, medicine, and an understanding of space. He worked flawlessly, until we looked too deeply. At the beginning of the 20th century, when physicists began to explore the world of atoms, they discovered something that did not fit into any framework. The behavior of matter at the smallest level turned out to be more than just strange. It turned out to be illogical, paradoxical, and most importantly, it seemed inextricably linked to the very act of observing it. The classic dream of objectivity began to crack. At first, they tried to blame it on the imperfection of the instruments or the incompleteness of the theories. But one experiment, conducted in countless variations with incredible precision, showed the same result over and over again. The passive observer principle is a lie. The most famous, simplest, and most frightening experiment in the history of physics did not simply show us a new property of the world. He destroyed the world as we knew it. He proved that there is no gap between me and the universe, that we cannot just watch. Our own perspective is an act of creation, and that changes absolutely everything. The central piece of evidence that destroyed classical physics and placed the observer at the center of reality is the double-slit experiment. In its simplicity, it is brilliant. His conclusions are terrifying. Imagine a wall with two narrow parallel slits. Behind it is a detector screen that records where the particles land. Now, let's begin our experiment. First, we will pass something understandable through the slits, for example, small balls. As expected, the balls flying through one or the other slit will create two distinct bands on the screen opposite each slit. This is the world of common sense. Now let's make it more complicated. Instead of balls, we will use waves, for example, waves on water. When waves pass through two slits, they interfere with each other. The crests of some waves combine with the crests of others, amplifying them. The ridges collide with the depressions and cancel each other out. As a result, instead of two stripes, we see a complex pattern of many alternating stripes on the screen, an interference pattern. This is also logical and predictable. And now, the magic begins. The true black magic of the quantum world. We will pass electrons, fundamental particles of matter, through the slits, and we will do this one at a time to prevent them from colliding with each other. Each electron flies out alone. Common sense tells us that an electron is a particle like a ball. It must fly through either one slot or the other, and after we release thousands of single electrons, we should see two bands on the screen. But that doesn't happen. To our utter amazement, an interference pattern slowly emerges on the screen, dot by dot, the one created by waves. That seems impossible. How can a single electron create such a pattern? The only logical explanation is that each individual electron somehow passes through both slits simultaneously, like a wave interfering with itself, and then becomes a particle again to leave a single dot on the screen. An electron exists as a probability wave that explores all possible paths at once. But that's only half the story, and not the scariest. Physicists, being skeptics, decided to trick nature. They thought, let's see which slit each electron passes through. We will place a tiny detector at the slits that will record the passage of electrons. We just want to know his path. We won't touch it. We'll just see. And the moment we do that, everything changes. The moment we set up the detector to find out the path of the electron, the interference pattern disappears. Absolutely. Instead, two ordinary stripes appear on the screen, like from balls. The very fact that we are observing the system, simply obtaining information about which slit the electron passed through, causes the electron to change its fundamental behavior. It ceases to be a wave of probability and becomes an ordinary particle with a clear trajectory. Remove the detector and electrons become waves again. Place the detector and they become particles again. The universe seems to know that it is being watched and behaves differently. This is not a metaphor. This is not philosophy. This is an experimental fact that has been repeated thousands of times. Observation is not a passive process. This is an active intervention that transforms vague quantum probabilities into concrete classical reality. We don't just look at the world. With our gaze, we force him to choose what he should be. And this conclusion contradicts our experience so profoundly that even 100 years later, we still cannot fully accept it. It means that objective reality existing on its own, until it is observed, may simply not exist. The double-slit experiment left us with an unpleasant conclusion. Observation changes reality. But he left a loophole for common sense, the loophole that Albert Einstein himself desperately clung to. Perhaps the world is objective after all. Perhaps particles have predetermined properties that we simply cannot see. This idea became known as the hidden variables theory. The essence of it is simple. An electron is not a wave and a particle at the same time. It is always a particle. It simply has a kind of hidden master plan or instruction manual that tells it where to fly. And when we see an interference pattern, it is not because the electron passes through both slits, but because thousands of electrons with their hidden instructions line up in such a pattern. This idea was a lifeline for classical intuition. She gave us back a world that exists on its own, realistic and predictable. God does not play dice after all. We just don't see all the rules of the game. For decades, this debate remained philosophical. There was no way to experimentally verify whether these hidden variables existed. But in 1964, Irish physicist John Stuart Bell did something incredible. He transformed this metaphysical debate into a concrete mathematical prediction. He derived a theorem that became known as Bell's inequality. The essence of Bell's theorem is as follows. If the world really obeys local realism, that is, if particles have hidden variables, realism, and if no influence can propagate faster than light, locality, then correlations between measurements of two entangled particles can never exceed a certain mathematical limit. Bell provided us with a clear experimental test. Take measurements, calculate the correlations. If the result is below Bell's limit, then Einstein is right and the world is objective and local. If the result exceeds this limit, then Einstein was wrong, and we live in a universe that is either unreal or non-local. And since the late 1970s, physicists have been conducting these tests. At first, they were inaccurate, but with each decade, technology became more and more sophisticated. Experiments were conducted with photons, electrons, and atoms. The distances between particles increased from meters to kilometers. The loopholes were closed one after another, and the result was the same, every time, without exception. Bell's inequality was violated, and it wasn't just violated. The results of the experiments coincided exactly with the predictions of crazy quantum mechanics. It was a death sentence for local realism. It was the final nail in the coffin of our intuitive world. Bell's experiments prove that we are faced with a terrifying choice. Either we must abandon realism, that is, accept that particles have no properties until they are measured. That the moon really doesn't exist when no one is looking at it. Either we must abandon locality, that is, accept that there is instantaneous, spooky action at a distance. That measuring one particle here can instantly affect another at the other end of the galaxy. Both options are insane. Both options destroy the very fabric of what we consider to be reality, but now we have irrefutable experimental evidence. One of these crazy options is true. Common sense is dead, and we killed him with an experiment. Bell's test presented us with a choice. Either the world is non-local or it is unreal. But what if it's even worse? What if it is also non-linear in time? The double-slit experiment showed that obtaining path information about a particle destroys its wave behavior. But what if we decide whether or not to obtain this information after the particle has already traveled its path? This idea belongs to the genius John Archibald Wheeler and is called the delayed choice experiment. And its modern implementation is known as a quantum eraser. And she takes the absurdity of reality to its absolute limit. Imagine our setup with two slots, but this time we'll make it more cunning. We create a pair of entangled photons. Let's call them photon A and photon B. Photon A flies toward our screen with two slits. Photon B travels along a long detour to a completely different part of the laboratory. We can place a special crystal at one of the slits that marks photon A, allowing us to know which slit it passed through. This tag is root information. As we expect, if we mark photon A, the interference pattern disappears. He behaves like a particle, but now his confused brother, photon B, enters the game. It arrives at its detectors much later than the photon A has already hit the screen. And with photon B, we can do two things. We can send it to a detector that will determine its state, and thereby confirm the path information of photon A. Or we can send it to a so-called quantum eraser, a device that mixes the paths and erases this information so that we will never be able to know which slit photon A passed through. And this is where reality breaks down. When we look at the data collected by the photon screen, it appears to be a random set of points, no pattern. But then we start sorting them. We only consider cases where its twin brother, photon B, entered the eraser. And lo and behold, from these random points, an interference pattern begins to emerge. Now we consider those cases where photon B hits the detector, confirming the path. And in this group of points, we see two clear bands without any interference. Let's repeat. Photon A hits the screen. His fate seemed to be sealed, and only then, in the future, do we decide what to do with its entangled partner. Photon B, delete the information about the path or keep it. And our future decision determines how Photon A behaved in the past. If we decide to erase information, he behaved like a wave in the past. If we decide to keep it, he behaved like a particle in the past. This does not simply violate causality, it ridicules her. This means that the past is not fixed and unchangeable. It remains a field of probabilities, a vague quantum maybe, until future observation confirms it as a concrete was. The choices we make now determine not only what will happen, but also what has already happened. The universe is not a book we read. This is a book that we write and erase simultaneously in all directions of time. Experiments inexorably lead us to a conclusion that seems like both megalomania and paranoia at the same time. Reality does not exist in a definite form until we interact with it. Our choices in the present shape the past. Our perspective here influences events there. Summing up these decades of shocking discoveries, physicist John Archibald Wheeler formulated this as the concept of a participating universe. He rejected the idea of the universe as a giant mechanism that operates on its own. Instead, he suggested treating it as a self-exciting circuit. In his opinion, the universe is like a giant cycle. It begins with the Big Bang, develops over billions of years, creates stars, planets, and ultimately life. And this life, as it develops, gives rise to observers, us. And by looking back at the relic radiation from distant quasars, we transform the vague quantum probabilities of the early universe into a concrete classical history. At the end of the cycle, observers give reality to the beginning of this cycle through their actions. It's like an Ouroboros, a snake biting its own tail. The universe creates observers, and observers create the universe. This is not just a beautiful metaphor. This is an attempt to make sense of experimental facts. If our choices now determine the behavior of photons billions of years ago, then this means that we are participating in the creation of cosmic history. We are not just passive viewers of a film about the universe that was shot long before we appeared. We are simultaneously viewers, editors, and perhaps even cameramen who, with our attention, choose which of the many possible shots will become reality. This idea gives us an incredible feeling of power. We are not just dust in an indifferent universe, we are essential participants in its existence. But with that comes a daunting responsibility. If our perception creates reality, then what kind of reality are we creating? Which story do we choose from the endless possibilities? And the most troubling question raised by Wheeler's concept is what existed before the first observer. Did the universe exist in any form during those billions of years when there was no one to observe it? Or did it only become real at the moment when the first act of conscious observation illuminated her past? We are moving from physics to metaphysics. But this is metaphysics born from the most rigorous and precise experiments ever conducted by humankind. The idea of a participating universe presents us with a pressing and, as yet, unresolved question. What exactly is considered observation? What is that magical ingredient that transforms the ghostly world of probabilities into the solid world of facts? Where does this mysterious line run? This puzzle is known as the measurement problem in quantum mechanics, and it is the biggest skeleton in the closet of modern physics. Let's follow the chain. We have an electron in superposition. It is both here and there at the same time. It interacts with the detector. Now the electron and the detector become a single entangled system. The detector also enters superposition. It simultaneously showed here and showed there. Then, the signal from the detector goes to the computer. Now the entire system is in superposition. The electron detector and the computer. The computer simultaneously recorded here and recorded there. Then you look at the computer screen. Now you and all the equipment are one big quantum system. You are in a superposition of saw here and saw there. But in your subjective experience, there is no superposition. You always see one thing. You see a concrete result. So where did the wave function collapse occur? Where exactly the world made its choice? The great physicist John von Neumann analyzed this chain and came to the conclusion that there is no point within the physical world where this collapse should have occurred. Any physical device can be described by the laws of quantum mechanics, which means that it can itself be in superposition. Detect a computer, even your eye and your brain, all of these are complex but still physical systems consisting of atoms. And there is no known physical law that explains why, at some level of complexity or size, quantum rules should cease to work and give way to classical certainty. Von Neumann suggested that collapse occurs only when information reaches something that lies beyond the description of physics, outside the world of matter. He suggested that this something is consciousness. This idea seems shocking and unscientific to us. It introduces something immaterial into physics. But from a purely logical point of view, it is one of the possible solutions to the measurement problem. If the entire material universe obeys the laws of quantum superposition, then the collapse must be caused by something non-material. This does not prove that consciousness creates reality, but this shows that our current laws of physics are incomplete. They lack a key element, a description of how and why our world becomes defined in the first place. The problem of measurement becomes even more acute and paradoxical if we consider it from the perspective of different observers. This brings us to the famous thought experiment proposed by Nobel laureate Eugene Wigner and known as Wigner's friend. This experiment takes the idea of the role of the observer to its logical and frightening conclusion. Imagine that your friend is in a completely isolated laboratory. Inside this laboratory, he conducts quantum experiments, for example, measuring the spin of an electron. As soon as your friend looks at the device, reality will make its choice. The probability wave collapses and he will see a specific result, let's say spin up. From his point of view, the superposition is destroyed. The world has become certain. But now let's look at this situation from your point of view. You are outside this airtight laboratory. You don't know what result your friend saw. From the point of view of quantum mechanics, until you receive information from the laboratory, you must describe the entire laboratory as a single, giant quantum system. This implies that the entire laboratory, including your friend and his brain, is in a state of superposition. There is one version of reality in which your friend saw spin up and is happy. And at the same time, there is another version of reality in which he saw spine down and is disappointed. For you, your friend is in two states at the same time. He is both happy and upset. He knows one result and he knows another. He is in a state of quantum schizophrenia. And this superposition will only collapse when you open the door and ask him, "So, what's going on with you?" Only then will reality choose one of the versions for you. So who is right? Your friend for whom the collapse happened earlier? Or you, for whom it happened later? Quantum mechanics does not provide an answer. She says that both points of view are correct within their own frameworks. This leads to a split in reality, to the idea that there is no single objective reality for everyone. Reality becomes relative. What is a fact for one observer is merely a possibility for another. This completely destroys our idea of a unified and harmonious world. Instead, we get a patchwork quilt of multiple subjective realities, each defined by the acts of observation of its own participants. And there is no supreme arbiter, no eye of God that could say which of these realities is true. Each of them is true for its observer. This is a world without foundations, a world without common ground beneath our feet. And this is a logical consequence of the most basic principles of our most successful scientific theory. We found ourselves at a conceptual impasse. On the one hand, the physical world seems to be completely describable by the laws of quantum mechanics, which state that everything can exist as a superposition of probabilities. On the other hand, Our conscious experience is always definite and concrete. We never experience two states at the same time. This gap between the quantum description and classical experience leads some physicists and philosophers to consider the most radical and heretical hypothesis. What if consciousness is not just a passive recorder of events? What if it is the very missing element, the very collapsing agent we are looking for? This idea, known as the von Neumann-Wigner interpretation, suggests that consciousness plays an active and indispensable role in shaping reality. According to this point of view, the wave function does not collapse when interacting with an inanimate detector or computer. The entire material chain from electrons to neurons in the observer's brain remains in a state of gigantic, entangled superposition. And only when this information enters the field of non-material consciousness does a miracle occur. Probabilities become facts. Maybe becomes is. This does not mean that our thoughts can change the world by force of will, as in magic. This means that the very act of conscious perception is the process that causes the universe to assume a certain state. Without consciousness, the universe would remain an eternally existing but never realized cloud of probabilities. A phantom garden of branching paths where all possibilities exist, but none of them are real. Consciousness in this model is not a byproduct of evolution that arose in the brains of primates. This fundamental and irreducible property of reality is as real as space or energy. It is a necessary condition for the existence of the classical world. This idea provokes fierce opposition from most scientists because it seems unscientific. It takes us beyond materialism. But it is important to understand that this is not mysticism or religion. This is one of the logically consistent attempts to solve the measurement problem. It may be incorrect, but it shows how deeply our best scientific theories force us to rethink the very foundations of our worldview, including the nature of ourselves. If this hypothesis is correct, then we are not merely co-creators of the universe. We are the spark that ignites her reality. We are the way in which the universe ceases to be merely a mathematical equation and becomes a living, experiential reality. Let's put together the pieces of this shattered picture of the world. Classical science promised us an objective reality that exists independently of us. But quantum mechanics destroyed that promise. The double-slit experiment showed that the very act of observation changes reality. Bell's test proved that particles do not have predetermined properties. The world is fundamentally undetermined until measured. The quantum eraser experiment showed that our choices in the present can influence events in the past. Wheeler's concept of a participatory universe suggested that we are necessary participants in the creation of cosmic history. The measurement problem revealed the fact that there is nothing in our physical laws that explains why the world becomes definite at all. And Wigner's thought experiment took this idea to its extreme by suggesting that reality may be subjective and relative to each observer. We have come to a conclusion that turns the entire scientific paradigm upside down. There is no such thing as objective reality independent of the observer. The universe is not fundamentally a set of hard facts. This is a field of pure potential, an ocean of possibilities, and we observers are catalysts who cause this potential to crystallize into concrete facts. We don't just study the world, we interact with it at the most fundamental level, and this interaction gives rise to what we call reality. This means that we must abandon the idea of passive knowledge. We cannot simply obtain a map of an existing territory. The process of creating a map changes the territory itself. It's a feeling of immense responsibility. If reality is a dialogue, then we must be very careful about the questions we ask. Because the answers we receive will become the world in which we live. We can no longer hide behind the mask of an objective observer. We stand at the center of creation not as its masters, but as its indispensable co-creators. And every glance we cast, every choice we make, every act of cognition we perform is a brushstroke on the canvas of reality. We stand atop a mountain of shattered illusions. There is no solid matter. There is no absolute space and time. And there is no objective reality. What remains? Only the process itself remains. The process of interaction, the dialogue between potential and relevance, between the system and the observer. Reality is not what it seems. This is what becomes known. This is a fundamental shift in our understanding. We are no longer searching for the ultimate substance from which the world is made. We study the rules of interaction that give rise to its visibility. This conclusion gives us a feeling of loneliness and omnipotence at the same time. Loneliness because there is no longer solid ground beneath your feet. There is no external objective truth to rely on. We are sailing in an ocean of subjectivity and complicity. But also omnipotence, because we understand that we are not simply passive victims of circumstances. We are central players in the game of reality. Our consciousness, our choices, and our act of observation have cosmic significance. They transform the ghostly world of quantum maybes into the classical world of is. It's a frightening freedom. We can no longer simply accept the world as it is. We are compelled to acknowledge our role in its continuous creation. And that brings us to the final and strangest stage of our journey. If all reality is a process of interaction, if the universe is a system that responds to our requests, measurements, and gives us answers, results, if all this is built on a network of non-local connections, entanglement, doesn't this whole structure resemble the workings of a giant computer? Isn't what we call physical laws actually algorithms? And what we call reality is the result of a calculation. We have reached the final layer of deception, to an idea that until recently was considered the stuff of science fiction and marginal philosophy. But today, it is increasingly discussed by leading physicists and cosmologists. What if the universe isn't just unreal in the sense that we thought it was? What if it is unreal because it is a simulation? The idea that we live in a simulation has become popular in pop culture. It is usually presented as something created by an advanced civilization, like a giant video game or experiment. But the hypothesis that physics has led us to is much deeper and stranger. It's not that our reality is simulated on some computer in another, more real universe. The point is that our universe itself, in its fundamental nature, is a kind of computer. That calculation is not what happens inside the universe. This is what the universe is. Let's call it the computational universe hypothesis. She brings together all the oddities we have discovered into a single and surprisingly logical picture. Why the world seems immaterial and made up of information. Because any calculation is based on bits of information, not atoms of matter. Why space and time are not fundamental but emergent. Because any computing system creates its own structure similar to space-time from simpler rules. Consider the world of video games. It contains space, time, and physics. But in reality, it's just the result of the code running on the processor. Why reality seems non-local and everything is connected to everything else? Because in calculations, information can be linked logically rather than geometrically. Variables in code can be linked to each other regardless of where they are located. Why reality is not defined until observation. Because the system can save resources and not calculate the result until it is requested. This is called lazy evaluation in programming. The system does not render the part of the world that you are not looking at. This hypothesis transforms all the frightening paradoxes of quantum mechanics into expected and even necessary properties of such a system. The creepiness of the quantum world is not a bug. That's a feature. It's simply how a computing system looks when observed from within its own generated patterns. We are ready to put all the pieces of the puzzle together and consider this hypothesis seriously. We are going to investigate evidence that suggests our reality may not be physical, but computational. That we and everything around us are simply complex patterns of information unfolding according to a set of initial rules. That all of this is simply executable code. We are entering the fourth and most abstract act of our investigation. We hypothesize that the universe is not simply described by mathematics and information, it is mathematics and information. It is not a physical world, but a gigantic, self-sufficient calculation. This idea seems wild, but let's treat it like a detective mystery and examine the evidence. If you were a program living inside a computer, how would you figure out that your world isn't the basic reality? You would look for signs that reveal its computational nature. And the first and strongest piece of evidence is that the world around us, at the most fundamental level, appears to be digital rather than analog. What does that mean? The analog system is continuous. You can zoom in infinitely, and you will always see smooth transitions. The digital system is discrete. It consists of indivisible basic units, pixels, and with sufficient magnification, you will see this grainy structure. So what is our reality? For centuries we believed it to be analog, but quantum mechanics has shown that this is not the case. Energy is not a continuous flow. It is transmitted in discrete portions, quanta. An electric charge can only be a multiple of the elementary charge of an electron. Even elementary particles are discrete units. But most importantly, as we have already discussed, space-time itself at the Planck level is most likely also discrete. It consists of indivisible quanta of space and quanta of time. This means that our reality has a finite resolution. There is a minimum pixel. This is a fundamental property of the world that is not at all obvious at our macroscopic level, but it is a direct consequence of our best physical theories, and it screams about the digital nature of our universe. The world does not consist of infinitely divisible matter, floating in infinitely smooth space. It consists of a finite number of discrete states that change in discrete steps. This is exactly how any computer works. It operates on a finite number of bits that switch from one state to another. If reality were a computer, we would expect to find precisely this kind of pixelated, quantized structure at its core, and we find it. This does not prove that we are living in a simulation, but this is very strong evidence that makes us think. Perhaps the smooth and analog nature of the world we perceive is just high-quality rendering, an illusion created by a basic digital machine. The second clue in our detective investigation into the digital nature of reality is even stranger and more abstract. It is related to information. In our everyday world, we think of information as something intangible. But in physics, information is a physical quantity. Any bit of information must be recorded on some physical medium, whether it is the orientation of an electron spin or the position of a molecule. This implies that information must obey the laws of physics. And one of the strangest conclusions from studying black holes is that there is a limit to information. You cannot cram an infinite amount of information into a limited amount of space. Physicist Jacob Bekenstein calculated this absolute limit, which is now known as the Bekenstein limit. It determines the maximum amount of information that can be contained in any area of space with a given volume and energy. It's like your hard drive has limited capacity. You cannot store more data on it than its physical structure allows. But the strangest thing about this limit is that it depends not on volume, but on the surface area surrounding that volume. This is the holographic principle we were talking about. But right now, we're just interested in the fact that this limit exists. If the universe is an infinitely complex analog system, then there should be no limit to information. You could store more and more information simply by recording it more and more accurately at increasingly finer levels. But if the universe is a digital computing system, then the existence of such a limit is absolutely natural. Every computer has limited memory and limited computing power. The existence of the Bekenstein limit suggests that our universe may operate with limited resources, as if it has a finite amount of RAM and a finite processor clock speed, Planck time. This explains why everything becomes grainy and discrete at the Planck level. The system simply cannot process information with a higher resolution. She doesn't have enough resources for that. This idea also sheds light on the nature of the laws of physics. Why do they even exist? In the computational universe, the laws of nature are not some kind of mystical external rules. These are simply algorithms for compressing information. This is the most effective way to describe the behavior of the system. The universe may behave in such a way that its description is as simple and concise as possible. It's like how we compress files into archives. We find patterns in the data and replace them with short rules. Perhaps the laws of physics are simply a zip archive of our reality. This makes the world less mysterious, but also much more mechanistic. We live within a system with limited resources that operates according to compression algorithms. This is not the majestic and infinite universe we dreamed of. It is something much more like an effective but limited machine. The third piece of evidence pointing to the computational nature of our reality is the very structure of the laws of physics. We are accustomed to thinking of them as passive descriptions of how the world works. But what if they are active instructions? What if these are not laws but algorithms? Let's take a closer look at this. Any fundamental law of physics, from Newtonian mechanics to Schrödinger's equation in quantum mechanics, can be viewed as a rule that takes the state of a system at one point in time and calculates its state at the next point in time. This is exactly how any computer algorithm works. It takes input data, processes it according to certain rules, and outputs the data. The universe seems like a giant system that executes its own code step by step. This idea is particularly evident in the concept of cellular automata popularized by mathematician John Conway and his game of life. A cellular automaton is an extremely simple computing system. It consists of a grid of cells, each of which can be in several states, for example, alive or dead. And there is a set of very simple rules that determine the state of each cell at the next moment in time depending on the state of its neighbors. For example, in the game of life, a dead cell with 3 living neighbors becomes alive, and a living cell with fewer than 2 or more than 3 living neighbors dies. That's all. No more rules. There is no central processing unit, no goal, only local interactions. And yet, these extremely simple rules can give rise to incredible complexity. You can see structures that move, gliders, structures that multiply, guns, structures that behave like primitive computers. You can see how a simple deterministic algorithm gives rise to behavior that appears alive and purposeful. Now, imagine a cellular automaton not on a 2-dimensional grid, but on a more complex structure, such as a graph or hypergraph. And imagine that the rules are a little more complicated. Is it possible that something indistinguishable from our universe could arise from such a system? That field particles and even space-time itself are not fundamental entities, but simply complex self-organizing patterns in this giant cellular automaton. This idea is not just theoretical speculation. Physicists such as Stephen Wolfram are actively working on such models in their Project Physics. They show how the evolution of simple networks of abstract relationships can give rise to special relativity, quantum mechanics, and even general relativity. This turns our understanding of complexity upside down. We are accustomed to thinking that complex things must have complex causes. But the computational paradigm tells us the opposite. An incredibly complex universe can be generated by a very simple algorithm running for a long enough time. And if that is the case, then our reality is nothing more than the result of the execution of this ancient and elegant code. If the universe is a giant cellular automaton operating according to simple rules, then what is the fundamental building block of this reality? What is that cell that can be in the on or off state? The answer to this question brings us to the fourth and most profound piece of evidence, to John Archibald Wheeler's idea, which he expressed in his famous phrase, "it from bit." It is anything, any physical entity, an electron, a photon, a galaxy. Bit is the fundamental unit of information, a binary choice of yes, no, 1, 0. The phrase "it from bit" asserts that neither matter nor energy is the basis of everything. Information is at the heart of everything. Everything, every it, ultimately comes from intangible bits of information. Let's figure out what that means. In the old physical picture of the world, information was secondary. First there was an object, for example Earth. Then we could describe this object using information, its mass, its radius, its speed. The information was simply a description of reality. But Wheeler suggested that the opposite was true. The information is preliminary, and physical reality is secondary. There is no such thing as an electron. There is simply a set of answers to binary questions that we can ask nature. Is the electron spin up? Yes, no. Did he go through the left slit? Yes, no. It is precisely these answers, these bits of information, that constitute what we call an electron. An electron is not a thing. This is an information structure. This idea fits perfectly with what we know about quantum mechanics. As we have seen, particles do not have definite properties until we measure them. Measurement is essentially asking nature a question and receiving an answer. This is an act of registering information. It is at this moment that information is created and reality becomes defined. The universe in this worldview is not a giant mechanism. It is a massive information processing system. Every interaction between particles is not just a collision. This is an exchange of information. This is a calculation. The laws of physics are not what govern matter. This is what controls the flow and processing of information. This point of view is known as digital physics. It offers a completely new paradigm. She tells us to stop searching for the ultimate matter. She's not here. Instead, we should look for definitive rules for processing information. This is the final dismantling of the material world. We start with the idea that matter is vibrations in fields. Then we saw that fields and space-time can be emergent products of quantum connections. Now we see that these connections themselves may simply be informational relationships. There is nothing at the bottom of the rabbit hole, no substance, only clean information, only bits, only answers to yes-no questions. And all the magnificent complexity of our world somehow arises from this simple binary code. If we accept the hypothesis of a computational universe, then all the oddities of the quantum world that have tormented us throughout our journey suddenly become not only understandable, but even expected. They cease to be paradoxes and become natural properties of the system observed from within. Let's go over them again in this new light. Why reality is not defined until observed. Why an electron can be both a wave and a particle at the same time. In the computing universe, this can be explained by the principle of lazy computing. The system does not waste resources calculating the exact state of each particle until it is needed. Until a query, measurement is made, the system maintains the particle in an economical state of superposition, like a compressed file containing all possibilities. Only when the observer requests specific information does the system perform the calculation and return a specific result. Why non-locality and spooky action at a distance exist. Why entangled particles can instantly influence each other. In ordinary space, this is a paradox, but in a computer, it's trivial. Two variables in code can be linked to each other regardless of where they are stored in memory. A change in one is instantly reflected in the other. If space is simply an emergent structure, then fundamental connections in the code are not required to obey its geometry. Entanglement is not a spooky connection across space. This is a direct logical connection in the code of reality. Why the past may be undefined and dependent on the future, as in the quantum eraser experiment. In the normal world, this is a violation of causality, but in computing, it may simply be a process of optimization. The system can recalculate and update past states based on new information to maintain overall consistency of the simulation. It's similar to how in video games, the system can retroactively load or modify details of the world that were not in the player's field of view. The past is not an immutable record. This is a dynamic database that can be updated. The computational universe hypothesis offers an elegant and unified explanation for all these seemingly unrelated quantum oddities. She tells us that we have been trying to understand the world using the wrong metaphor. We thought it was a mechanism, but it's a calculation. We thought it was a world of objects, but it's a world of information. The creepiness of quantum mechanics is not a property of reality itself. This is a characteristic of our incorrect perception of it. These are not bugs in the workings of the universe. These are the features of its operating system. The idea of the universe as a giant cellular automaton or computer found its most complete and ambitious development in the works of physicist and entrepreneur Stephen Wolfram. For decades, he has argued that we are looking for answers in the wrong place. Instead of trying to fit the universe into complex mathematical equations, we should see if it can arise from very simple rules that can be executed on a computer. His physics project is an attempt to find the fundamental code of reality. In Wolfram's model, there is nothing but abstract relationships between abstract points. These relationships form a giant hypergraph, a complex network where everything is connected to everything else. And there is one simple rule that dictates how this network should be updated. Step by step. The rule is simple. For example, find a specific small pattern on the network and replace it with another. And that's all. In the beginning, there is no space, no time, and no particles. There is only this network and the rule for updating it. Wolfram and his team ran simulations of the evolution of such networks on supercomputers for a variety of different simple rules. And they discovered something remarkable. From these extremely simple ingredients, structures emerge that behave exactly like our physical reality. The network itself begins to behave like space. The number of connections between points begins to behave like the dimension of space. And most importantly, network updates that are distributed across it behave like particles moving in this space. Their interactions obey rules that look exactly like the rules of quantum mechanics. Moreover, the very structure of this growing network generates effects that are mathematically equivalent to Einstein's general theory of relativity. Gravity in this model is not some mystical force. It is simply an inevitable statistical property of how this fundamental network grows and bends. Wolf's model shows how all the physics we know, quantum mechanics and relativity theory, can be a byproduct of a very simple computational process. Space, time, matter, energy, none of these are fundamental building blocks of reality. All of these are emergent macroscopic properties underlying the calculation. This is not just a philosophical idea. This model makes specific predictions that can be tested. For example, it predicts that at the most fundamental level, there may be tiny deviations from the laws of special relativity, that particles with masses not predicted by the standard model may exist. And if even one of these predictions is confirmed, it will be a revolution in physics. This would mean that we finally looked behind the scenes of the interface and saw a glimpse of the real code of reality. We have reached the very peak of abstraction, to the point where the tongue almost stops working. We trace the path from solid objects to vibrating fields, from fields to emergent space-time woven from quantum connections, from connections to calculations based on simple rules. Now we must ask the final question of this act. What is the carrier of this calculation? What is the bit that lies at the very foundation? The answer is provided by John Wheeler and his concept of it from bit. And to understand its depth, we must turn our thinking upside down. We are accustomed to thinking that reality exists first, and then we ask questions about it. But it from bit says that the opposite is true. First, there are questions. Binary yes/no questions, and reality itself is born from the answers to them. Imagine the universe as a giant game of 20 questions. But in this game, there is no object that needs to be guessed in advance. The object is created in the process of answering questions. Every time an interaction occurs, whether it is a collision between two particles or a measurement in a laboratory, the universe asks itself a question and receives an answer. This answer is one bit of information, and the sum total of all these bits of information is what we call the universe. There is no underlying substance in this picture of the world. There is no matter. There is only information. Reality is not something we discover. This is what we build with our questions. Each measurement is not a passive reading of data. It is an act of creation that adds another bit to reality. This perfectly explains why reality is not defined until observation. Because before the question is asked, the answer simply does not exist. The universe is not a book with text already written. This is a blank page on which we and other processes in the universe are constantly writing history through our interactions. This is the final dismantling of the material world. There is nothing solid at the bottom of a rabbit hole. There is no final particle. There is only an intangible process of information exchange. Reality is not a noun. It's a verb. It is a continuous process of development. And we are an integral part of it. We don't just live in the universe, we are the beings whose questions force her to be. And that is the deepest and most disturbing thought of all. If the world is based solely on information, then our entire physical reality is simply a giant information structure. Magnificent and complex, but no more real than program code or a mathematical theorem. Now that we are armed with the hypothesis of a computational universe, we can look at all its paradoxes and see in them not errors, but elegant logic. All the oddities we discussed earlier come together to form a single, consistent picture. This is a moment of intellectual catharsis, when chaos turns into order. We no longer have to put up with the madness of the quantum world. We can understand him. The illusion of matter. Why does the world seem empty and consist of fields? Because it is not objects that are fundamental, but information and the rules for processing it. Matter is simply a stable pattern in this flow of information, like an icon on your computer desktop. It looks like an object, but in reality it is just a pointer to a data block. The illusion of spacetime. Why space and time are not fundamental, but emergent. Why non-locality exists. Because space-time is simply a data structure that the system uses to organize calculations. It is convenient for creating a macroscopic world, but at a fundamental level of code, it does not exist. Therefore, information can be linked logically rather than geometrically. The illusion of objectivity. Why reality is not defined until observed and depends on us. Because the system optimizes its resources. She does not calculate all possible outcomes in advance. It performs lazy calculations and determines the state of the system only upon request. Our observation act is this request that forces the system to perform rendering and return a specific result. There are no more paradoxes in this picture of the world. There is only one working system, and we observe it from within. It's like a character in a video game trying to understand their world. He would have discovered strange things, invisible walls, enemies appearing out of nowhere, the laws of physics that sometimes fail. For him, these would be paradoxes. But for us players, we know that these are not paradoxes. These are simply features of the game engine. Invisible walls are the boundaries of the map. Enemies are the result of scripts. Physics glitches are simply bugs in the code. The hypothesis of a computational universe allows us to view our world from the perspective of a player. She tells us that all quantum weirdness is just a feature of our game engine. They are not a sign that the world is irrational. On the contrary, they are a sign that it is built on very rational and efficient computing principles. We have finally found a language in which we can describe quantum reality without mysticism and madness. It is a programming language. We have come a long way in dismantling reality, and now we can put all the pieces together into a single hypothesis. The universe is not a world that contains computers. The universe is a computer. And what we call physical reality is simply a conclusion of his work. Its graphical interface. Let's summarize. We started with the illusion of matter and saw that the world is based not on substance, but on information. This is our file. Then we looked at the illusion of space-time and realized that it is not a container, but an emergent data structure. This is our file system. Then we encountered the illusion of objectivity and realized that reality does not exist prior to observation. This is our on-demand rendering system. And finally, we combined all of this into a hypothesis about the computational universe. This is our operating system. This hypothesis is the most economical and, at the same time, the most comprehensive of all those we have considered. It does not require the introduction of new entities or laws. On the contrary, it explains existing laws and entities as emergent properties of a simpler, basic process. She explains why mathematics is so incredibly effective in describing the universe. Because the universe is, by its very nature, a mathematical structure. She explains the mystery of the origin of the laws of nature. These are not external decrees, but internal rules of the system. She explains the nature of time as a sequence of computational steps. She explains the nature of space as a network of informational connections. She even offers a possible solution to the problem of consciousness. Consciousness in this model can be defined as a certain type of complex self-referential computation. A pattern that is aware of itself. Of course, this is just a hypothesis. We don't have definitive proof, but it has enormous explanatory power. It transforms the world from a collection of unrelated mysteries into a single logical and understandable, albeit counterintuitive system. It provides us with a new and powerful paradigm for exploring reality. We should no longer ask, what is it made of? We should ask, how is this calculated? We are moving from physics to what could be called infophysics. And this could be the greatest revolution in science since Copernicus and Newton. We are on the verge of realizing that we live not in a material universe, but in an informational one. So we have reached the climax of our investigation. To the conclusion of the fourth act. The universe may be an illusion because it is, by its very nature, an interface to a giant computing system. This conclusion gives us a sense of intellectual catharsis and acceptance of unreality. But it also raises a new set of profound and disturbing questions. If we live in a calculation, what is the nature of this calculation? Is it deterministic, or is there room for true randomness? If everything is predetermined by an algorithm, what happens to our free will? Is it just an illusion, a sensation that arises from complex computational patterns? Or the system itself may be so complex that it allows for unpredictability and true freedom? What is the purpose of this calculation, if there is one at all? Was the universe launched for some purpose? For example, to solve a complex problem or to generate consciousness? Or it has no purpose and simply operates on its own as a natural phenomenon? And the most important question that torments everyone who encounters this idea. If the universe is a program, then who or what is the programmer? Is there a creator who wrote the code and started the simulation? This question takes us beyond the realm of science and into the realm of metaphysics and theology. The hypothesis of a computational universe does not provide an answer to this question, but it allows us to formulate it in a new way. Perhaps we are looking for an external programmer out of habit because all the programs we know were written by someone. But what if the universe is a special kind of calculation, one that does not need a creator, one that can arise spontaneously and work on its own? This brings us to the final and most breathtaking act of our journey. We will have to consider the possibility that there is no one behind the great code of reality. That logic and mathematics alone may be sufficient to give rise to the universe. We will have to face the most frightening and at the same time most liberating idea. With the idea of a self-sufficient reality created by no one, we will have to look into the face of the impersonal and indifferent abyss of mathematical existence. We are on the verge of the final act. We armed ourselves with the most powerful and comprehensive hypothesis, the idea that the universe is a giant calculation. This idea explained all quantum oddities and reduced them to peculiarities of the information system. But she left us with one final and most terrifying question. If the universe is a computer, then where is it located? And who started it? This question seems natural, but it is a trap. It is based on our intuition from the macroscopic world, where there is always a distinction between a program and the computer on which it runs, between software and hardware. But at a fundamental level, there may not be such a difference. Perhaps we are asking the wrong question. Perhaps no external programmer and no external computer are needed. Perhaps the universe itself is a self-sufficient system that is both code and executor. It does not exist in any particular place or time. It exists in the abstract space of mathematical possibilities. This brings us to the most dizzying leap into the abyss, to the last series of questions that will take us beyond physics into pure metaphysics. What if there is no deceiver behind the great deception of reality? What if the system exists simply because it is logically consistent? What if mathematics is not just a tool for describing the universe, but the universe itself? We are going to consider Max Tegmark's mathematical universe hypothesis, which states that any mathematically existing structure also exists physically. We explore what this means for our own existence. Are we just self-aware parts of a giant mathematical object? And finally, we will ask the most fundamental question of all. Why does anything exist at all, rather than nothing? And let's consider the shocking possibility that this incredibly complex computational structure could have arisen from absolute and complete nothingness. This is the final stage of our dismantling. After him, nothing will remain but pure amazement and possibly pure horror. We have come to the final question, which seems to be the logical conclusion to our investigation. If the universe is a calculation, then where is the supercomputer on which it is running? This question troubles everyone who encounters this idea for the first time. It conjures up images of giant servers hidden in another higher dimension, images of creator programmers watching our world on their monitors. But this question, despite its apparent naturalness, is a profound conceptual trap. He is the ghost of our macroscopic thinking, which we try to stretch onto a reality where it no longer works. We are accustomed to dualism. There is a program, and there is a physical device that executes it. There is word program code, and there are silicon chips in your laptop. One is abstraction, the other is matter. But what if, at the most fundamental level, this division does not exist? What if the universe is a special kind of computation that does not require an external medium? What if it is both software and hardware? Imagine a mathematical structure such as the Mandelbrot set. It is an incredibly complex fractal object defined by a very simple equation. Where does it exist? It is not located in any physical place. It exists in the abstract Platonic world of mathematical forms. He doesn't need a computer to exist. We only need a computer to visualize it, to make it visible to our perception. But the set itself, with all its infinite details, exists eternally and unchangingly, regardless of whether we think about it or not. Now, imagine that our universe is the same kind of mathematical structure. Much more complex, but essentially the same. It's not running on anything. It just is. Its existence is its calculation. Every step of its evolution, every interaction between particles, is simply an exploration of its own inherent logical structure. In this picture of the world, there is no division between description and what is being described. Physics equations are not a description of the universe. This is the universe. It is its own simulator. This idea frees us from the need to search for an infinite regression of creators. If our universe is simulated, then who simulates the universe of the creators? And so on, ad infinitum. The hypothesis of a self-sufficient universe breaks this vicious circle. There are no simulation levels. There is only one fundamental reality, the reality of mathematical and logical consistency, and we are part of it. This knocks the last support out from under our feet. We were looking for a creator, a programmer, a machine, but we find only a pure, cold, impersonal, and eternal structure. There is no behind the scenes. The stage is everything that exists. The idea that the universe is a self-contained mathematical structure found its boldest and most formal expression in the mathematical universe hypothesis, proposed by cosmologist Max Tegmark. This hypothesis takes the final and most radical step in our departure from intuitive realism. She asserts the following: any mathematical structure that is logically self-consistent does not simply describe a possible universe. She is the universe. In other words, Mathematical existence and physical existence are one and the same. Tagmark calls this the principle of mathematical democracy. Any consistent mathematics has the right to physical existence. What does this mean in practice? This means that our universe, with all its complex laws, particles, and fields, is not unique or special. It is just one of an infinite number of mathematical objects that exist in the gigantic library of all possible logical structures. Next to our universe in this Platonic world, there are other universes that are much simpler or unimaginably more complex. A universe governed solely by Newtonian mechanics. A universe consisting of a single cellular automaton. A universe with 27 spatial dimensions and 12 types of magical powers. Everything that can be described consistently using mathematical language exists just as realistically as our world. We do not live in a world that can be described by mathematics. We live in a world that is mathematics. This idea evokes intellectual coldness and a feeling of profound loneliness. It deprives our universe of any sense of being chosen. It was not created. She was not chosen. It simply exists as one of infinite logical possibilities. There's nothing special about it, except for one thing. It turned out to be complex enough to give rise to structures capable of realizing their own existence. That is, us. According to the Tegmark, we are simply self-aware substructures within a giant mathematical object. Our existence is a property of this particular mathematics. This hypothesis is elegant because it does not require any arbitrary assumptions or initial conditions. She answers the question of why the universe can be described so well by mathematics. Because it is mathematics. It explains the fine-tuning of the universe. There are an infinite number of universes with different settings, but by definition, we can only exist in the one whose parameters allow for our existence. But the price of this elegance is high. We are losing our uniqueness. We become simply an inevitable consequence of the existence of all possible logics. We are a theorem that has proven itself. If we accept the hypothesis of a mathematical universe, we must face its most disturbing consequence, which concerns our very nature. If the universe is mathematics, then what is I? What are my consciousness, my feelings, my memories, my free will? The answer to this hypothesis is simple, ruthless, and elegant. All of these are also mathematical patterns. We are self-aware substructures, SAS, within a giant mathematical object. Let's break it down piece by piece. What is structure? It is simply a set of relationships between elements. A musical score is a structure. A social network is a structure. Your brain, with its trillions of synaptic connections, is an incredibly complex structure. What does self-aware mean? This means that this structure is complex enough to process information about itself. She can create an internal model of herself and the world around her. She can perceive, remember, and predict. From this point of view, consciousness is not some kind of mystical substance. This is an emergent property of a certain type of complex, recursive information structures. This is what mathematics feels when it thinks about itself. This leads to an identity crisis. My love for another person is simply a complex correlation between two information patterns. My sensation of pain is a specific type of computational process that signals damage to my structure. My sense of free will is an illusion, arising from the fact that I cannot predict the outcome of my own complex algorithm. We are becoming computational processes that are aware of themselves. Stable, recursive information loops existing within an eternal and unchanging mathematical reality. But does that mean we are unreal? No. Within this hypothesis, we are as real as everything else. We are as real as mathematical patterns. Our experiences, our feelings, our thoughts, all of these are real properties of this structure. This is not an illusion in the sense of deception. It's just not what we thought it was. We considered ourselves souls trapped in bodies, and we may turn out to be algorithms executed on the fabric of mathematics. It's like a character in a very complex book. This character is fictional, but his suffering, his joy, his story, all of these are real parts of this book. They exist as information, as structure, and if this book is complex enough, perhaps this character can begin to recognize himself as a story. He may start asking, "Who am I?" And the answer will be, "You are this story." That doesn't make it any less real. It simply defines the nature of its reality. And perhaps that is the most accurate description of who we are. The realization that we may be nothing more than mathematical patterns causes a natural fear. The fear that if fundamental reality is unreal in our usual understanding, then our lives, our experiences, and our values become meaningless and devalued. If all this is just code or equations, then what difference does it make how we live? What is the difference between love and hate, between compassion and cruelty? But this fear is based on a misunderstanding. The unreality of the foundation does not negate the reality of emergent levels. Let's draw an analogy. Imagine Beethoven's symphony. At a fundamental level, these are simply fluctuations in air pressure that can be described by mathematical equations. Does this mean that the beauty, power, and emotional impact of this symphony are unreal? Of course not. Beauty is an emergent property that arises at a higher level of organization, at the level of our perception and our consciousness. It is absolutely real as an experience, even if its foundation is just physics. Or imagine the novel War and Peace. At a fundamental level, it is simply ink on paper, a set of symbols. Does this mean that the story, the characters, their tragedies and triumphs are unreal? No. They exist and are real at the level of information and meaning. Similarly, even if our universe is, at a fundamental level, just a mathematical structure, this does not devalue the reality of our experience. Our pain is as real as the information process. Our love is as real as a complex correlation. Our sense of meaning is real as an emergent property of our consciousness. Levels of reality do not cancel each other out, but complement each other. Knowing that wet asphalt is made up of atoms doesn't make it any less wet. Knowing that a rainbow is a refraction of light does not make it any less beautiful. And knowing that we may be complex mathematical patterns should not make our lives any less meaningful. On the contrary, it may give it a new, deeper meaning. This means that our experience is not a random byproduct of an indifferent material universe. Our experience, our consciousness, our search for meaning, these are some of the most complex and interesting patterns that this mathematical structure can generate. We are the way the universe knows itself. We are her eyes, her ears, her mind. And in this sense, our life, even if it is a mathematician's dream, has incredible value. We have established that our experience can be real even in an unreal universe. But this brings us to the final existential question, the question of meaning. If we live in an impersonal mathematical structure that was not created by anyone and has no purpose, then what is the meaning of our lives? Traditionally, humanity has sought the answer to this question externally, in the divine plan, in the laws of nature, in historical necessity. We were looking for an objective, pre-established meaning that we only had to find and follow. But the hypothesis of a mathematical universe tells us that this makes no sense. The structure simply exists. She is neither good nor bad. She has no goals or intentions. It is simply logically consistent. This means that the universe is fundamentally indifferent to our existence and our search for meaning. It sounds like a sentence to existential despair, but it can also be the greatest liberation. If there is no inherent, objective meaning, then that means we cannot go wrong in searching for it. Any meaning we find or create is, by definition, local and subjective, and that doesn't make it any less valuable. Meaning is not what we find. This is what we, as complex self-aware structures, create. This is an emergent property of our consciousness, not a fundamental property of the universe. This is our function. We are machines for producing meaning. We look at the indifferent patterns of mathematics and see beauty in them. We observe chaotic interactions and refer to them as life. We build relationships, create art, and seek knowledge. All of these are acts of creating meaning in a world where there was none to begin with. This puts us at the center of our own existential project. We can no longer shift responsibility for the meaning of our lives onto God, nature, or fate. This responsibility lies entirely with us. This is the horror and grandeur of freedom that existential philosophers spoke of. We are thrown into an indifferent universe, but we are free to paint any picture we want on its canvas. In such a universe, there is nothing more or less meaningful. A scientific discovery, a work of art, an act of kindness, love for another person, all these are patterns of meaning that we create and that are as real as we are ourselves. We don't need to search for the meaning of the universe. We need to create it. And perhaps this is our main and only purpose. We have reached the bottom of the rabbit hole. We have reduced reality to an impersonal and eternal mathematical structure. But even here, there remains one final, most fundamental question that has tormented philosophers and physicists for centuries. Why does anything exist at all rather than nothing? Why does this complex mathematical structure exist rather than just absolute emptiness? The traditional answer is some kind of creator or eternal cause. But the hypothesis of a computational and mathematical universe allows us to approach this question from a completely new and shocking angle. What if this incredibly complex structure arose from absolute, complete nothingness? Not from the quantum vacuum, which, as we have seen, is teeming with energy, and from the true philosophical nothingness, the absence of everything: space, time, matter, energy, laws, logic, the very concept of existence. At first glance, this seems absurd. Nothing comes from nothing. But let's think about it. What is nothingness? This is a state of complete symmetry. There are no special features or differences in it. It is perfectly stable. Any something is a violation of this symmetry. The emergence of the universe from nothingness is a spontaneous violation of this ideal symmetry. How is that possible? Some physicists, such as Lawrence Krauss, suggest that the total energy of our universe may be exactly zero. The positive energy of matter and radiation is precisely compensated by the negative energy of the gravitational field. If the total energy is zero, then no energy is required to create the universe from nothing. It can arise from quantum fluctuations in nothingness without violating the law of conservation of energy. It's a lunch that no one pays for. But even this idea presupposes the existence of quantum laws prior to the universe. What if we go even further? What if logic and mathematics themselves are the only things that can arise from nothing without any reason? Why? Because nothing, by definition, cannot contain contradictions. And a logically contradictory universe, where 2 + 2 = 5, cannot exist even as a concept. This means that the only type of something that can spontaneously arise from nothing is a logically self-consistent structure: mathematics. In this worldview, the universe could not simply have come into being out of nothing. It had to happen. Because nothingness is inherently unstable in relation to the birth of consistent logical systems. This is the most mind-blowing twist of all. The universe may not just be a deception, it may be a deception that arose from nothing, exists nowhere and never, and is fulfilled by no one, simply because it was the only logically possible alternative to complete non-existence. This means that the basis of everything is not presence, but absence, not existence, but non-existence. And our entire existence is just a fleeting ripple on the surface of this eternal and silent nothingness. We are at the end of our journey. Let's look back at the road we've traveled. We started with the solid and reliable reality of common sense, and step by step, relying on the most rigorous conclusions of modern physics, we dismantled it to its very foundations. We saw that matter is an illusion, emptiness structured by fields. We realized that space and time are not an arena, but an emergent projection, perhaps a hologram. We were confronted with the shocking fact that there is no objective reality independent of us, and that our perception is an act of creation. we explored the hypothesis that the universe is a giant calculation, and we are patterns in that calculation. Finally, we looked into the face of the impersonal mathematical abyss and the possibility that all this splendor arose from absolute nothingness. What now? How can one live with this knowledge? The first instinct is rejection. It is an existential anxiety, a fear of losing all support. But the second step is acceptance. The bitter but liberating acceptance of a new worldview. Yes, reality is not what it seems. It is much stranger, more subtle, more abstract than we could have imagined. But that doesn't make it any less significant. Our experiences, our feelings, our searches, our relationships, all of these are real events unfolding within this incredible structure. Accepting this new reality is similar to how humanity once accepted the fact that the Earth is not the center of the universe. At first, it was humiliating and frightening. But in the end, it gave us a much more majestic and accurate picture of space. Similarly, abandoning our intuitive realism may initially seem like a loss, but in reality, it is an acquisition. We are gaining a deeper understanding of our place in the universe. We cease to be mere random clumps of matter in an indifferent void. We are becoming an integral, necessary, and perhaps the most interesting part of this gigantic, self-aware information process. We are not just spectators. We are the show. Accepting this is the final step toward intellectual and existential maturity. This is a rejection of a child's need for a simple, comfortable, and material world, and accepting an adult, complex, and exciting reality built on information, logic, and consciousness. At the very beginning of our journey, we suggested that the universe might be an illusion. And all along the way, we searched for the deceiver. We suspected our feelings, the laws of physics, hidden programmers. But now, at the very end, we come to the final and most paradoxical conclusion. Perhaps the greatest deception of the universe is that it has made us believe that we are separate from it. Our entire culture, our language, our science are built on this fundamental division. There is I, and there is the world. There is the observer, and there is the observed. There is consciousness, and there is matter. We live within this duality. But everything we have learned from physics screams that this division is a lie. At the quantum level, there is no clear boundary between us and the world. We constantly exchange matter and energy. Our act of observation is inextricably linked to what we observe. In the hypothesis of a mathematical universe, we are not external inhabitants, but internal substructures. We are not something that exists within the universe. We are the way in which the universe itself locally realizes itself. We are her nerve endings. We are her eyes through which she sees herself. When you look at the starry sky, it's not just photons hitting your eye. It is the universe that, through the complex structure that you are, comes to know its own beauty and its own past. When a scientist derives a new equation, it is not simply a person describing the external world, it is the very mathematical structure of the universe, which, through one of its patterns, reveals yet another aspect of its own logic. The realization of this unity is the true enlightenment to which science leads us. This is not a mystical feeling, but a strictly logical consequence. There is no deception. There is only our mistaken idea of ourselves as something separate. And the horror we have experienced throughout this journey is the horror of the ego, which fears its dissolution in this universal unity. But behind this horror lies a feeling of deep involvement, the feeling of coming home. We are not abandoned in a strange and indifferent universe. We are this universe, experiencing itself in an infinite variety of forms. We were looking for solid ground under our feet, but found only an endless network of relationships. We were looking for definitive answers, but found only deeper and more interesting questions. We embarked on this journey hoping to understand whether the universe is real. Instead, we realized we had been asking the wrong question. The question is not whether it is real. The question is, what is it? And the answer we got is that it can be a process, a gigantic, self-sufficient, self-aware information process. And there is no endpoint in this process. There is no final revelation. There is no ultimate truth that can be found and settled. The purpose of this process may not be to reach some kind of conclusion. The goal is the process itself. This endless unfolding of complexity, information, and self-awareness. We are accustomed to thinking of knowledge as the accumulation of facts. But perhaps true knowledge is not accumulation, but participation. Participation in this great cosmic dialogue. Every scientific discovery, every work of art, every act of cognition does not bring us closer to the end. It simply makes the process richer, more complex, and more interesting. He adds a new branch to the ever-growing tree of knowledge, and we, as conscious beings, are at the forefront of this process. We are its active agents. We are the ones who ask questions, who seek answers, who create new levels of complexity and meaning. This is our cosmic function, and perhaps that is our destiny. Not finding paradise, not reaching nirvana, not getting all the answers. Just keep playing. Continue participating. Continue asking questions. Continue to be curious, creative, and conscious participants in this endless and beautiful process that is the universe. We will not find peace in answers. We can only find it in an endless and exciting search, and in the realization that being part of this quest is the greatest privilege of all. We started with a simple and disturbing assumption. The universe may be an illusion, and this deception is terrifying. And we have seen this for ourselves. We saw all our foundations crumble: matter, space, time, objectivity. We have encountered ideas that cause dizziness and existential fear, with the idea that we live in a simulation, with the idea that we are simply mathematical patterns, with the idea that all this arose from nothing. Yes, it's terrifying, but at the end of this journey, looking back, we see that this is not the whole truth, because there is another side to each of these terrifying ideas, the side of incredible beauty and elegance. Yes, the world is not material, but it is the most delicate and complex information structure. Yes, we can be programs, but we are programs that can be self-aware, love, create, and ask questions about our own nature. Yes, all of this could have come from nothing, but the very fact that such incredible complexity and such profound consciousness could arise from absolute nothingness is no cause for horror. This is a cause for reverential awe. It is the greatest miracle imaginable. Perhaps the real deception lies not in the fact that the universe is unreal, and in the fact that we focus only on the horror of this unreality, forgetting about its beauty. Reality is not what we thought it was, and that's okay. Science is not about confirming our preconceptions. It's about their destruction, and behind every wall of our illusions that is destroyed, a view of a much grander, stranger, and more beautiful landscape opens up. The universe may be an illusion, but it is the most magnificent, the most complex, and the most thrilling deception of all possible deceptions. This is our deception, and that is the only reality we have. And it's not just terrifying. She is also beautiful, and living within this mystery, being part of it, trying to unravel it, that is what makes us human.